Okay, video 2, 8.2, number 2, we're going to introduce complex fractions in section B. You're used to doing a problem like this to where people would have you get the common denominator on top and the common denominator on the bottom and invert and multiply. But what we're going to do is we're going to play what's missing. But it's very important that we know in every one of these complex fractions, that means a fraction within a fraction, that we must make sure each term in the numerator and the denominator has a denominator. And then I'm going to have you circle the denominators after you put in the ones if need be. After we circle the denominators, you're going to need to find the LCM of those denominators, and the LCM of 4, 6, 8, and 6 is 24. When you've played what's missing earlier, which we're used to doing with numbers, when we're doing fractions and equations, the 4 needs the 6 needs the 4, and the 8 needs the 3. So you're going to come and give the 4 a 6, the 6 a 4, and the 8 a 3. Now, all textbooks will tell you that you're supposed to be multiplied by 24 over 24, and you're supposed to multiply and then cancel and get the 6, multiply and cancel and get the 4, multiply and cancel and get the 4, multiply and cancel and get the 3. But what we're going to do is just simply state what is 4 missing from the common denominator, what is 6 missing from the common denominator, and what is 8 missing. And so when we put what's missing next to the numbers, notice these have already, the things in the circles are just going to go away. We're not going to even see them anymore. We're just going to use those numbers up there. And we're going to have 6 plus 4 over 4 plus 7, and we're 10 over 7. So this is all that we're going to do, is that we're going to lie and say we've done this, but we're going to play what's missing. Now, in reality, all of the problem, here's your original problem. I know I've mushed up the numbers, so here's the original problem. What you're going to do is go ahead and circle those, put in the what's missing numbers. So the only 3 steps you actually have on your paper are where you fixed up all the work in the original problem I give you. Then you have the result, and then the compilation. So, what are we going to do? Here's the next problem. Oh no, x and 1 don't have a denominator. So I gave x and 1 a denominator. What else do I need to do? Circle the denominators, because this helps me find the LCM or the LCD, which is y. And what am I supposed to do according to the book? Multiply by y over y, but what are we going to do? We're going to say 1 is missing the y is missing 1 is missing y is missing 1. Because when you're looking for the LCM, y needs nothing and 1 needs y. So here's your original problem right there. You are literally going to come all the way down here. You'll put in the 1s in the original. You will then circle the 1s, and then you will put in all the what's missing numbers in the original problem. So now we go ahead. What's left? We ignore these again. Remember, those are gone because when we pay what's missing, we've already factored and reduced. So we go ahead and get our product, which is xy minus the x, and then the product's y minus 1. Now, of course, you have to factor, and in this case, we're going to factor the numerator. with a common factor, which is the kind we always forget. So the common factor is x, and lo and behold, look at y minus 1 and y minus 1, they reduce. Now remember, you really, for other teachers, need to show y over y. You need to lie to let teachers think that you actually distributed and reduced, that you actually went y times this, then canceled, y times this and canceled, and so on. I know you're not going to do that. You're going to be a bum like your teacher. So here's the problem. What do I need to do? Put in the ones and circle them. So here's the original problem. So here's now what my original problem looks like. I then ask, what's the LCM for my original problem? My lowest common multiple is x squared. So what does 1 need? X squared. What does the x squared need? Absolutely nothing. What does the x need? An x to get to x squared. So I put in my what's missing numbers. 1 needed x squared needed 1, 1 needed x squared, x needed x. And again, I'm going to say I'm multiplying by x squared over x squared, but by playing what's missing, we have already done the reducing, and there's our problem. And so now we have 9x squared minus 1 equals 3x squared minus x. Again, we need to factor. This time, the numerator is the difference of squares, and the denominator is the common factor. After we common factor, we see that both terms have 3x minus 1. Both numerator and denominator have 3x minus 1. And since these are all multiplies and divides, we can divide, simplify, reduce, cancel, and we get 3x plus 1 over x. We're done because nothing else simplifies. Because, guys, you can't cancel this. That's a plus sign, not a time sign. That's a plus sign, not a time sign. That's a plus sign, not a time sign. And now we're going to move to the next room to continue with our video. You get to have a picture of my hand. So I try to work my way around. Now, an example like number 8. Let me get out of the glare of the light if I can. Here's the original problem. Notice I put in the ones and I circled the denominator. When I looked at those circled denominators, I see 1x and x squared. So the lowest common multiple or common denominator is x squared. 1 needs an x squared, x needs an x, and x squared needs a 1. So again, I lie, LOL, and say I'm going to actually distribute 5 times when I'm really going to say 1 needs x squared, x needs x, 1 needs x squared, x needs x squared needs 1, and I'm going to ignore these because I've already canceled them. That's why they're circled. We always ignore our circles. And what's left? X squared minus 3x over x squared minus 2x minus 3. Now the numerator is going to be a common factor and the denominator is an easy trinomial. The factors of 3 are 1 and 3. 3 is larger, so he gets the negative sign. And then we always try to reduce. And we get, when we reduce, x over x plus 1. Again, I cannot cancel those. That's a plus 1. I can't cancel those. That's a plus, not a times. Now life is going to get interesting. We're going to be mixing monomials and binomials. Note, when we come in here, that we have 2 minus x. People keep texting me, folks. I have to keep clearing the screen. I'm so sorry. 2 minus x, which I must rewrite. And again, I need to negate because I want this x minus 2. So that's negative x over x minus 2 down here. Now I'm ready to play the game. Anybody that doesn't have a 1 gets a 1. I circle my denominators, and what is the common denominator? The lowest common multiple is x minus 2. The x minus 2 needs a 1, and the 1 needs an x minus 2. So coming over to the next slide, You'll notice x minus 2 needed 1, 1 needed x minus 2, and so forth. When I come in, so again, these, we ignore everything circled because what's missing takes care of the reducing part as we go. So I distribute and get x minus x plus 2 for the top and x minus 2 minus x for the bottom. Don't try to cancel yet. You have to combine terms. And when I combine terms, well, lo and behold, it's 2 over negative 2 and a cute little negative 1. All right, another problem. Just the same thing, but now I've got a quantity I need to factor. So I common factor it, and here I'm ready to go. I see that my lowest common multiple is a times a plus 15. I play what's missing. A needs a plus 15. A times a plus 15 needs 1, and a plus 15 needs a. So here is really the problem. Yes, I know I have to rewrite it in factored form, but some people don't even do that. You already know that this term is just that, so you could have left it that way. So I have my a plus 15, my 1, my a plus 15. This is telling me I was really multiplying, but remember, when we play what's missing, we've already done the reducing. So I do my distributing, 2a plus 30 minus 36, and 6a minus 15. I now must combine. I cannot cancel until I've combined everything that I have. So I have 2a minus 6 and 5a minus 15. Again, I can't reduce. I have to common factor the numerator and denominator. And now these quantities match. So now I can reduce them. And my answer is 2/5. The last example for problem 11. So here's problem 11. Wow, notice we don't have to do anything with the factoring. We just have to put in the ones and the circles, and the common denominator is x minus 2. So we play what's missing. It's really easy. 1 needs x plus 2. X minus 2 needs 1. The 1 needs x minus 2, and the x minus 2 needs 1. And remember, you're technically multiplying by x minus 2 over x minus 2. But we've played what's missing, so we've already canceled those. So we distribute 2x minus 4 plus 4 gives me 2x, and 2x minus 4 plus 5 gives me 2x plus 1. Again, I cannot reduce because remember, that is the same as saying something like 2 over 2 plus 1. You can't cancel the 2's and tell me it's 1. Don't be a turkey. Don't gobble. This is a plus sign, not a time sign.